Hello boys and girls, and welcome to lesson 7-4, subtracting linear expressions. We will also be looking at 7-5, factoring linear expressions. If you need any further assistance, please take a look at the examples found on pages 310 to 313, as you can see right there. Okay, something I want to address here is that there's different ways to solve linear expressions. Now here we're being shown one way to do it. Here we're going to subtract. We have this expression right here minus this expression. Over here we have 3x's, and then we take away 8 negative x's. Okay, remember when you take away, you're actually adding, right? When you take away negatives, you're actually adding. And then you have your constant here. And remember, the reason we call it a constant is because it doesn't have a variable to change its value. Okay, so here we're going to subtract this value from this value. So we're looking for the difference. Okay, there's a couple of ways that we could do it. We could write it like this and then use commutative property, okay, to put the like terms together. Okay, you can put them together so that it's easier to work with them. So we took away the parentheses, wrote it as a long equation, but remember, taking away negatives actually changes this to a plus sign. You see how that was changed to a plus sign? And then we go ahead and we find the like terms together. We put those together to make 11x, and -6 and -5 and -1 together make -6. Okay, that's one way to do it. Another way to do it would be to write it vertically. So now I have I wrote my 3x minus 5 right there, and below it I'm going to write minus, in parentheses, -8x plus 1. Okay, a positive 1. So what happens here? How does this work? Okay, I'm going to have a -5, okay, -5 right here, and I'm going to take away 1. You take away just a regular 1. -5 take away 1 is -6. Okay, and now I have 3x's, positive, minus -8. Minus is adding. So you're taking away 8 negatives, so it's adding, so it's really going to be 11x. And here is your simplified version of this expression. Okay? Take a look at number 21. Okay, let's rewrite it over here vertically. So first I write my 3x plus 2. There it is. So let's pay attention to the expressions that we have. We have a positive 3x and a positive 2. Got it? And my operation is subtracting. And I'm going to subtract a positive 5x and a positive 6. Okay, there's no negative being subtracted. Notice that? So the operation is subtraction, as you can see right there. So really I have 3x minus 5x. Okay, it's going to give me -2x. And then I have 2, okay, 2 minus 6. Minus 6. What value is that going to give me? It's going to give me a -4. Okay? -4. So you notice that here was addition, but it's no longer addition. It's changed to negative because the value changed to negative. This addition is essentially telling us that we're adding 2. It's a positive 2, and here's a positive 6. Okay? Go ahead now, pause the video, and try 22 and 23 so we can check those in class. Let's do 24 together. Number 24. One week, Ty made 3x plus $4. Okay, we're not sure exactly how much he made. Maybe we don't know how much he's actually making an hour. We could say he worked 3 hours at X amount of dollars per hour plus $4. We can say that that's what that's representing, right? The following week he made X amount or dollars per hour plus 8. Okay. How much more did he make the first week? Okay, how much more he made the first week? So it looks like we're looking for a difference. A difference means subtracting. The way I would write this out, I would write it as 3x plus 4, and I'm going to subtract because I'm looking for the difference. I'm going to subtract the x, and I'm going to subtract the 8. Okay, and when I do so, I go ahead and I move down, so I have 3x minus x, taking away 1x, so now I have 2x's left, right? And 4 minus 8 is -4. And that's dollars. Okay? If you have any questions, please ask me in class. Let's move on to 7-5. Lesson 7-5, Factoring Linear Expressions. For further assistance, you can look at examples found on pages 316 to 320. Here we have the expression 2x plus 6. As a model, it looks like this. We have 1x and 2x. See? 2 x's and 6 digits. Okay? Here's our coefficient, our variable, and our constant. Okay? If we were to arrange it, okay, into a rectangle, and we were looking for its dimensions, we can see that over here we have 1x and 3 singles, right? And over here we have another x and 3 singles, 3 digits. And then on this side we have two of them. We have 1 and 2 rows. Okay? If I asked you to factor it, I'm asking you to look for a common factor between all of this. And we know that we have 2. A common factor is 2. 1, 2 entire rows of it, right? So I can say I have 2 x's and 2 groups of 3 digits, don't I? And you can see it right here. Okay, we have 2x plus 6. Okay, we have between both of them 2 is in common. Okay, if I factor out the 2, whatever I have left over I can put in a parentheses. Now remember, parentheses implies that you're multiplying this 2 times in here, whatever is in here, the term. So 2, what do I have to multiply the 2 to get to 2x? Just x, right? And then what do I have to multiply the 2 to get my 6? 2 times 3. Okay. Do you see how that's been factored? 2 times x is 2x, and 2 times 3 is 6. Okay, so 2 is the greatest common factor. It's the GCF. And when we write it like this, we can use distributive property later to simplify. 2 times x is 2x. Okay? Like that. And then 2 times 3 is 6. And there you go. When we go from this to this, where I'm asking you to factor it. If you go from this to this, you're using distributive property. Okay? You're multiplying the number outside the parentheses with both expressions inside, or both terms inside the parentheses. So we're going to practice that from 25 to 32. Sometimes you might not find the greatest common factor, so we simply say it cannot be factored. Okay? Let's see. Let's try, for example, number 25. What is the greatest common factor between 4 and 12? Okay, 4x and 12. We know that it's 4, right? It's 4. I can write simply a 4 outside of it, and inside the parentheses. What do I have to multiply to get 4x? I have to multiply times x. And then the 4 times a number so I can get 12. 4 times 3. Okay? So go ahead and try 25 to 32. Okay, let me see if I find one that cannot be factored. Oh, I found one. 28 cannot be factored. There's no common factor. There's no greatest common factor between 5 and 12. So we simply say cannot be factored. Okay? But there is you can factor this one, you can factor this one, you can factor that one. Let's see over here. Yep, you can factor, let's see, this one is a multiple of 7 and 5, and this one is 6 and 3, 9. No, I don't think there's a common factor for this one. So this one, I don't think this one can be factored, unless you can prove me wrong. This one looks like 2, and this one can be factored as well. Okay, let's look at question 33 together. Decantra made a collage on a square sheet of paper poster board. Okay, the perimeter of the collage is 20x plus 12. And so this is the entire perimeter. Okay, all the distance all around it, centimeters. What is the length of one side of the collage? So here, what they're asking us, boys and girls. Now let me see if I can zoom this out so I have this area to work with. So what they're telling us is that we have a poster, a square, meaning all the sides are the same, right? They both all have to be the same length. So we have a square, and they're all equal sides. Can we make this? Can we divide it into 4? equally? Well, if I divide 20x divided by 4, okay, I'm going to get 5x, correct? And if I divide the 12 divided by 4, I'm going to have 3. So it looks to me like this is going to be the lengths for each side in centimeters. Because it's a square, don't forget. That's the tricky part. It's a square, so all sides are equal. So each side is 5x plus 3 centimeters. Okay? I just simply divided that by 4. Okay, go ahead and try 34. Please read it. It looks like what you have to do is factor 12n plus 144. Okay? And let's try 35 together. The area of a name card is 8x minus 2 square inches. This is the area. Okay, so if we have a card, okay, a name card, the area is 8x minus 2, and its area, so it's going to be squared, right? So factor 8x minus 2 to find possible dimensions of the name. So we're going to have to factor this so we can find a dimension for this side and this side. Okay, I can see that 2 is a factor, is a common factor. If I were to factor this, I would simply take out the 2, okay, 4x minus 1. You see, this is a possible dimension. So I could say that this side is 2, okay, 2, my 2 right there, and this side could be my 4x minus 1. When I multiply these two together, my length times my width, I will get this area. Does that make sense? Alright, boys and girls, we'll practice this further in class. See you then.